Okay, we're going to go through the steps for u substitution. I thought I would start with the trig function. So when you're looking for your u, you're still looking for an inside function, just like when you did the chain rule for derivatives, which is u sub 4 taking a derivative. So the inside function is the 5x, and I'm still looking for something inside of parentheses. So u equals 5x. Now, when you took the derivative, the next thing you would do is u prime, but u prime was du dx. So the derivative of u with respect to x is 5. Now, for integration, we are going to change this because I'm trying to get u's into my equation and du's into my equation. So I'm going to multiply both sides by dx. So du equals 5 dx. And you'll do this on every single problem. So what some people start doing pretty quickly is not writing this. They just go straight to this. So let's say the derivative is 5, and then they just multiply it by the dx or whatever the variable is, d, theta, dt, d, whatever. So now we're ready to substitute. So I do this in a couple of parts. First thing I look for are coefficients, and you can see that there's a 10 here. So you can pull the 10, just a number, a coefficient outside of the integral. And then I'm going to replace the 5x with my u, and I always put the u piece up front. So it will be secant squared of u. Now notice that I haven't substituted everything. I still have a dx, and for a while I'm going to do this in two parts for you. So I will write everything that's left, which is a dx. But you'll notice I have two variables here. I have u's and x's. You can't do that. So it is a two-part substitution. The next thing I have to substitute is this dx, and that is going to come from the du piece over here. You see this dx. So I need to know what dx is equal to. So I look at my du, and if I want the dx by itself, I would divide both sides by 5. So dx is equal to 1/5 of du. All right, so I'm going to rewrite this one more time before I integrate, and you're going to see that I now have two coefficients. I have a 10 and a 1/5, so you will multiply to combine those. So 10 times 1/5 is 2, and then I'm going to write everything else I have. I have a secant squared u, and remember this dx got replaced with this, so I've used the 1/5 to change the 10 into a 2, but I still have a du. And now we're ready to integrate. So the 2 is just a coefficient, it comes down. And then because this is trig, you check the chart, you check for all your basic integration rules. And the integral of secant squared u du is tangent u plus c. And the reason for that is because the derivative of tangent u is secant squared u times u prime. So we are going to write tangent u plus c. And then for my very last step of substitution, I'm going to put my u back in. So u is equal to 5x. So this is 2 tangent 5x plus c. Now, if you want to check your work, you can. And this is the answer right here. But if I was going to check the work, I'd take the derivative. So the 2, the coefficient comes down. The derivative of tangent of u is secant squared u times u prime. So it's derivative of the outside, which is secant squared. Leave the inside alone, 5x, times derivative of the inside times 5. So if you look at that now, I have 2 times 5 is 10, secant squared of 5x, and the derivative of a constant goes away, and you can see the problem is right there. So we know we have the right answer.